Well, hi and welcome back to another episode of the New Old Computer Show. This is the never-ending series of Mac SE30 tinkering. We do have a working Mac SE30, which is an incredible step up from when I started this journey out back in what was it, November last year. I still have one SE30 that I couldn't revive, but that one helped me get this one up and running. So when where we left off last time, we had basically a working BlueSCSI V2, a great little device. This is a little bit of overkill for a 68030 computer. This is a device you want to put in, say, a Power Mac. But just for fun, because I had this kit, I decided to put it in this Mac, this older Mac. And what we had last time was a status LED that wasn't working. So we were using the LED that came with the well, it came with the computer basically. In the drive bay, there's a little LED that hooks up to the stock hard drive that came with this computer. But when we hooked that up with this BlueSCSI, which it has an LED header right up here, we got nothing. So I theorized that that was due to there being actually header for 3 pins here, but that was a red herring because that third pin is just another ground. So to troubleshoot this, and I spoiler, I kind of figured out what was going on here. But to troubleshoot this, you go back to you think about what makes an LED light up, right? And that is electricity, right? So if an LED doesn't light up, it's either, I suppose, broken somehow. Maybe it's falling apart inside, or it's not getting enough electricity, high enough voltage. So I'm no LED expert, but I think most of them are rated for 5 volts that you find in these systems, because they run on 5 volts typically, like the logic in these computers. Of course, newer devices like I'm pretty sure that this Raspberry Pi Pico runs on 3.3 volts. That's kind of the new standard for miniaturized electronics. But we want to have at least 5 volts to drive our old LED. So how do we figure out what's happening? Well, we use our trusty old oscilloscope, right? So here we have the scope all set up. That sits over here. Here's my 01 USB scope, very handy little scope. I also have an extra LED hanging out here. I'm going to use it for testing in a moment. That's a brand new LED. So yeah, so we want to see as when there is disk activity on the computer, we want to see what is happening on the LED header, right? So to do that, we want to let's see, so you can put it over here so you can see what's going on. So we're gonna hook up the ground. There is a handy ground pin it's just next. Well, it's one of the header pins, right? I put it there. Pull down the isolation so that it doesn't get shorted. So now when you start up the computer and it starts to access the emulated hard drive, we should be seeing spikes here on this. So right now it's at 0 volts. So just as a guide on how to read this, what you see here on the screen is the dotted line is plus 8 volts, and we have 4 partitions like in between the midline and 8 volts, which means that each one of those is 2 volts, right? So we would like to see 2.5 of these, a curve that hits 2.5 of these, right? So let's turn on the computer. So we saw a little bit of a jump there. There we saw another one. So you see pretty clearly that it's hitting just under 4 volts, right? See if I can pause when it happens. There we go. So here is the paused view. So as you can see, what we have here is just under 4 volts. And the good news is that, yeah, we have voltage on it, like there is electricity coming through, which of course you can see from the various status lights as well. But we also see that it's less than 4 volts, which is probably not the spec here, right? So for fun, we can take our fresh LED and put it, so the long leg on these is the positive, the anode, and then we put these two on here to see if we're getting, yeah, so maybe, there you see. So this fresh LED does have some, it's fairly faint, right? But you can see that there is activity. If I turn this off, it's, yeah, that's better. You can see that a fresh LED is certainly getting enough juice to light up a little bit. But the one that's that was originally in this computer, which we want to use because it's authentic, right? Does not get enough to support that. So another couple of things you can check, and this is I asked the experts. I asked Androda and Eric Helgeson what to expect with this, and yeah, less than 4 volts is definitely not enough. So one thing you can do is check the kind of voltage that's going into this board, and one place you can do that is on the this header here, power on. So it's right here, and you see that that's also just under 4 volts. So there's nothing wrong with the LED circuitry. Like at first I was a bit suspicious of the resistor that sits on here. There is a resistor on R57, a teeny tiny, this guy here, R57. That's the one that's controlling the current that goes to the LED header. On the schematic, it's rated for, I think, 470 ohms, and that is exactly what it measures as well. So it's in spec. I don't think it's, or we can clearly see that it doesn't contribute to this problem. So where does this device get its power from? Well, it gets it from the termination power, right? That's the power that comes in through the SCSI bus, and that's in its turn gets its power from the 5-volt rail that comes in from the power supply. So a couple of things that we can do there. So you can always start at the source, right, to see what kind of voltage that we're getting through the power supply. So I'm pretty sure that, so I'm gonna just make this quick. So we have, these are the, 14 pins from the power supply that are under here. They're easy to reach there. That's why I like to use them. Let's just get the, maybe a little bit hard to see, but I'll just put that here so you can see what's going on. Maybe? Oh, that's too much glare. You can just about see what's going on there. Maybe you can tell. Like so. So let's just test. Pretty sure that we have one of the ground pins down there. And then I think the 5-volt is up here. And that's the 12 volts. Okay, so that's the 5 volts right there. So it's actually 4.89. That's a little bit low. That's actually a little bit low. minus 5.05, minus 11.82. Yeah, so problem number one is that we're getting ever so slightly low voltage. I think when I measured this early on, I got something like 4.96, I think. So it seems like the effort of driving the BlueSCSI is definitely taking its toll. Let's do a quick, I'm gonna turn off the computer. So let's see if when we unplug the BlueSCSI, if we're getting much more current or much more voltage. 4.93. Yeah, so you can see that's the effect that BlueSCSI is having on this circuitry. What was it before? 4.86 or something. So it's pulling like half, 0.05 volts, which is significant. It's pulling down the whole circuitry a bit. So I think step one thing that I think we want to start out with, since the voltage is a bit low, would be to pull out the power supply and adjust the 5-volt adjustment, the potentiometer controls the 5 volts. I think it's just one pot for the whole circuitry. It controls the 12 and 5 volts. So that's a bit cumbersome. We have to tear down this machine again, but I think it's worth to get a little bit more juice out of the power supply. So let's do that. I think didn't really plan on doing that, but I think that's probably a good thing to do. We want a little bit more juice. So let's discharge. I think my discharging tool. Okay. Let's do it like so. We should start out by unplugging the logic board, I think. Put that aside for a bit. And put it down here. And let's get rid of the high voltage in the CRT. I think I kind of put the it's a little bit risky perhaps, but I need to pull the ground strap up a little bit. I had put it a bit too close to the edge there. There we go. Let's plug that in, like so. Make sure it doesn't unclip. And that lift it a bit, yep. And yeah, the red coating is still coming off. So yeah, let's, so in order to get the power supply out, we have to kind of lift the entire analog board out to the side a bit. Which, well, as I mentioned, alternatively you have to unscrew the CRT, so which I prefer not to do. So let's quickly get this power supply out. This is kind of par for course when you are working on compact mechs. You have to tear it apart, assemble it, tear it apart again. It's really painful initially, but yeah, you get kind of used to it. Like so. So that's the analog board is loose. Yep. So next we want to also unscrew the power supply. And now you'd want to just lift this out of its clips there. Put the analog board to the side. It's good to unplug the neck board just as a precaution so you don't pull it off. And then we unplug the power supply that sits over there. It's always a pain to do. There we go. Okay, it's out. So let's hold up the analog board while we kind of pull the power supply out. So, okay, power supply is out. So let's unscrew the power supply. Just take all the screws. Be careful with the washers. So yeah, I think it's only those 3 screws on these power supplies. This is an Aztec made power supply, by the way. Aztec, like so. And there's always a bit of a trick to getting these open up, because they were clearly made, you know, to be child safe, so to speak, amateur safe. These manufacturers didn't want regular folks like us to open these. But I opened this once before, so it's a little bit easier. But if this is the first time you open one of these up, it's bound to be very stiff. Also good opportunity to check. So I have not recapped this PSU. That could be another thing that people will be screaming at me like, I need to recap this. And yeah, there's an argument to be made that you want to preemptively recap them. I prefer not to unless it becomes absolutely necessary. So I like to. So what you want to do with these is beyond the, so these large caps on the hot side here, those the AC voltage caps, they are typically of very high quality. They do not leak. But the other caps can be iffy. And in particular, what I've found is there is a special kind of, you can see very clearly here, these tall radial caps in brown packages. These are typically low ESR caps on the cold side of the board. They leak like crazy sometimes. So whenever I open these up after you use them for a while, you want to check that they haven't started leaking. So yeah, if you plan to kind of refurbish one of these and then send it off or put it in a closet or something and forget about it, yeah, you want to probably recap these preemptively. But personally, I'm gonna, as long as I own this machine, I'm gonna be taking it apart every now and then and check what's going on. So I'm not in a hurry to recap this. And yeah, I think it seems solid. I cannot see signs of leakage. Of course, initial leaks you can only notice if you take the caps off and look underneath. And in really bad cases, you will then start to see the brown grayish goop come out and out of the sides and come out onto the bottom of the board, and that's when you get real damage to components, to the leg. That these legs are gonna get corroded. The traces on the underside are gonna get corroded. The vias, through holes, are gonna get corroded. So yeah, all kinds of nastiness will ensue. So anyways, we want to track down the adjustment pot on this board. It should be somewhere. No, that's a screw. There are a couple of little daughter boards that sometimes have the adjustment on them. Nothing here. Yeah, this is not an easy one to track down. Yeah, now when I think of it, I don't think I adjusted this one. I adjusted the one that's in the SE over there. Yeah, think how silly it would be if I can't find the voltage adjustment on this board. That would be an embarrassing outcome. Okay, hold it close to the camera so maybe somebody can spot it. So I guess it must be on one of these little daughter boards. There's one daughter board sitting here. There's one sitting here. There's one over here. So from this vantage point, I don't see one on there. There's just a couple of coils, resistors. And here we have transistors and capacitors, ICs. So when you see an IC, that means usually the switching power supply control. Yeah, I don't see any pot on that either. So don't tell me that these Aztec PSUs don't have voltage control. They must have. They must have. That's, they adjust these in the factory. It's just hidden somewhere. It's playing hide and seek with us. It could be sitting, underneath some of these large overhanging components. So to make this easier, I should probably get it out of this enclosure. It might sit underneath here. But it would be so silly if they designed this power supply in such a fashion that you can't easily adjust it after you assembled it. That would be ridiculous. You'd want to be able to adjust these after quality control, right? So it must be hiding in plain sight somewhere, I'm sure. I am certain of it. Is it that? No, what is that? CC, it's capacitor. Okay, that's another capacitor. Diode, capacitor. Diode, resistor, capacitor. Come out, wherever you are. High pot. Oh. Is it hiding under this plastic cap here? Is that what it is? Let's see if I can pull this off. Well, I could pull off the cap, but that looks like an inductor or something, T2. Yeah, that's it's kind of funky looking, this thing here, T2, patent pending. Had this little cap on it. So since it said high pot there, I was thinking maybe it's an enclosure for a potentiometer. But to my eyes, that does not look like a potentiometer. Put it back on. Yeah, so this is a fruitless search. Let's pull these screws out. See if the potentiometer is underneath the board. No, I don't think so. That could not be the case, right? You don't want to put potentiometer underneath something. So 2 screws are out. Come out of there. I think in order to be able to lift this out, we have to uncrimp this plastic. There's a name for this, I forgot what it's called. But this is gonna be holding on to the board. These are usually kind of pain to get out, and I think there are specialized tools even to do this. I know there's a trick to this. I've gotten these out before. So there's only so much you can get underneath this without pulling that off. So let me just lift it up. Yeah, I'm just lifting it up and peeking into underneath. And I see no signs of any kind of components underneath, so I think that's kind of a useless endeavor to try and get inside. How about this side? So there are components on the other side of these. These little daughter boards. This is very annoying. I'm not sure how to adjust the voltage on this Aztec power supply. This is the first time I run into a power supply of this vintage where I just can't find the adjustment. It's not on the side here, right? No, that's a capacitor. Diode, a resistor diode. Yeah, I don't think there's a voltage regulator there. Hooked up to a very large heatsink, of course, because it's regulating a lot of electricity to not much electricity. So is it sitting underneath here? These cables here? No. Some caps down there. A resistor. Diodes. Capacitors. I think I'll have to ask around to hear what people are saying about this. Is that it right there? No, that's just a transistor. That as well. Nothing on this side. It's capacitor. Where is the darn potentiometer? Such a mystery. I wonder if there was some other Aztec used some other method to adjust. Maybe there was another. Where's that? DBI plus minus. I don't know what that component is. Coils, I guess here. L or inductor. More voltage regulators. Yeah. So this is certainly a fun stream, looking at person aimlessly searching on a little PCB for a component. Kind of have a hunch there should be something on this little daughter board that has the IC. That's kind of what I've seen before. But that's where you adjust. Does the pot sit down there? No. It's just a diode on there and a resistor. Bizarre. Truly bizarre. yeah, I guess until I figured out how to adjust the voltage on this one, and I mean, it was fairly minute. I mean, it was pretty low. The 5-volt rail was pretty low. We do want more, so I may actually let's switch gears. Let's see here. Let's put these, I guess, over here. I'm gonna put this power supply off to the side, and I'm gonna grab another AC30 power supply. So luckily, I guess, I have a second supply here. Now this is in much worse shape though, because this one has leaked a lot. This is not a happy power supply. So let's unscrew this. I wrote on here, it says must clean and recap. So yes, spoiler, I've been inside of this power supply, because you don't want to let the rot spread too much. Jeez. These screws are pretty stubborn, even though I've been in here before. I wonder if this ground lead needs to come off as well. Maybe, probably. There we go. Off you go. So I guess I need to, yeah, I need to unscrew these two as well, here, this one and this one. These are, hold on to a heatsink. There we go, now it comes off. So first look, you can see, here's where it starts, right? Here are signs of leakage. There is grossness that has come out, and you want to clean that up for sure. So I've left some of the components in this little baggie here when I first opened this up. And I'll demonstrate. So here's where the cluster of caps that were really gross. So I cleaned up what I could clean up, you know, from without taking anything else off. But here you can see this is the good stuff. This is where you have horribly corroded traces, right? All this black dotted stuff. This stuff needs to go. So you can see that the solder mask has started to come off, right? So yeah, I believe these supplies are made by Hitachi. I'm pretty sure Hitachi OEM. So the tricky part here is that you definitely want to take out components that have been in and around this leak. So that's kind of the heavy lifting here. And it's good to remember where the parts went, right, before you're taking out. So now I'm shooting a video of this, so I can always go back and inspect the footage, which is helpful. But I also like to take pictures. So in the bottom of the case, you can see here the cap leakage made its way down here, over here. So yeah, lots of grossness, and you definitely want to get that off. That's this is base, you don't want to neutralize this with light acids, mild acids such as vinegar, for instance. Otherwise, it will keep eating away at the metal. So yeah, not quite what I had planned for today. Let me put some water on my little sponge. But you roll with the punches. So yes, for my reference, I'm gonna just take a picture of this part of the board. So I definitely want to just desolder all of this. All this has to go. All right. Well, let's get the soldering iron out and the trusty solder plate. So yeah. Sorry, trying to find my flux. I think I dropped something on the floor. There, my flux was just fallen over on behind there. All right. So let's turn on the iron. Let's turn on the fume extractor. And let's see if we can desolder stuff. Yeah, I can smell the cap juice already. There's this distinct fishy smell when you work on cap juice infested parts. So that came out, and yeah, it has pretty gross legs. So I want to focus. Come on. There it is. You can see you want to clean up those legs for sure. We probably want to desolder this entire. Let's see here. Yeah, I think we want to desolder this entire cable assembly. Yeah, the solder here, it's so corroded that it doesn't even melt. There we go, it started to melt. Started to melt. It's very gross. There you go. You have to use a little bit more force with these leads, they're very thick. There you go. Yeah. This is fun. Now we have 5 ground leads to solder. That gets a little bit more. I should probably be using a bigger tip. we go. One more. There we go. Alright, so this whole cable assembly is out. So I'm gonna have to clean all of these contacts because they're all pretty corroded, I think. Or at least there's some grossness on them. Some disgustingness. And yeah. Probably want to keep going. Actually, oh, so what I was looking for earlier, let me just demonstrate. So this basically right here, a potentiometer like this is what I was looking for, and I couldn't find it. Hence this job. In fact, I should have shown. The reason I'm doing this is I actually have this cap kit. This is an entire kit for this power supply. I believe it's this power. It's the correct one at least. So as part of this, I'm going to actually replace all the capacitors. Just given the state of this thing, right? They probably didn't use the best components. Yeah, the solder doesn't even melt. Really struggles. Really struggles. Well, that came out. This basic capacitor. Diode. Oh yeah, of course it's diode. Big one. So it's good to keep an eye out on to make sure that the silk screen tells us the orientation, and it clearly does because of the white stripe there. So yeah, if you're careless and don't take notes or take pictures, and the silk screen doesn't do its job, then you may end up struggling to put things back together. Oh jeez. So as I was trying to pull out one of the resistor there, it's just falling apart. See if I can. He wants to focus on this. Right there. So it may just be the pack, like the surrounding the insulation, as it was. But yeah, I think I should put a different cap back. Sorry, resistor. Wait, is that a cap? No, it's a resistor. Okay. Because that one has fallen to pieces. Yum. I'm kind of more and more regretting this. Jeez. This is not happy. Well, since I was holding on to this power supply, you know, sooner than later, right? It's either you throw it out, you do something with it. There's some jumper wires here. I'm just gonna probably discard and then get new ones. These. Oh, I didn't desolder that yet. Okay. One resistor out. One jumper. Very gross. So like the holes there are so. Look at the black gunk coming out of those holes. Two holes. Ugh. Disgusting. One more jumper out. Ugh. Should probably you let me show off the nastiness under the microscope. Let's turn on the microscope. Do I have the microscope? Maybe I need to turn it back on. I think I unplugged it over here. Probably no, not that one. This cable. Maybe. Have too many USB devices. I can't keep track of that. Yeah, that was the right cable. It's on the side. So you have a good setup of GBA cases now. Trying to turn on my microscope. It's always very finicky. And you have to delete it, remove, add, do capture. There we go. So let me demonstrate. This is what I've. So to recap, sinusoid. Oh, nice. I try. Sorry, I'm getting distracted. So, just a quick recap. I started out by looking at the BlueSCSI to see what was going on with the LED, why it wasn't lighting up. I concluded that it's getting too little juice, like too low voltage. It's hovering at 3.8 roughly volts, which is not enough to drive the LED that we want to use it with. So I looked at the voltage rails that come through, and the 5-volt voltage rail, when it's just driving the logic board, it's, I think it was 4.94 or 6 or something, and then, but when you hook up the BlueSCSI, the voltage rails drops to 9.886 or something, pretty low. 4.86, sorry, 4. So it's well below 5 volts, right? It's not a disaster. The logic can still work, but it's, you know, borderline too low. So I took out the power supply that we were using. It's an Aztec power supply. It's in very good condition, but I failed to find the voltage rail regulate the potentiometer to adjust the voltage rail on this thing. So I switched gears and picked up a Hitachi-made power supply that I have in my closet, which is horribly cat juice corroded. You know, it's just in all that black gunk, black soot-like layer there. It's all corrosion. A lot of components have come off already, and some of the components are falling apart, and I'm starting to regret going down this path. But let me demonstrate. So months ago, I removed all the caps and discarded them because I didn't want more leakage to get into the circuitry. Actually, let's get some. I can see that sort of the cap juice is oozing out of the holes here. I'm gonna put some alcohol on there. I'm gonna wipe it off. Ugh, yeah, look at this. Look at that cap juice. It's so gross. On your side too. Oh yeah. Oh yeah. This PCB is gonna be pretty weakened. Actually, remove this as well. I'm just gonna desolder. Oh jeez. The traces are just coming apart. It's not healthy. So let me demonstrate what's come off so far. So this, I think this is in a coil. So you can see it. Ew, the legs there. That's all cap juice. This one too. cap juice. This needs to be cleaned. Here's a voltage regulator. Grossness. Look at that. Diode. Yuck. Resistor. Not too bad. But yeah, these have to be cleaned. And then things are falling apart. So this this resistor, for instance, it just came apart. Sort of the insulation on that thing is just coming off. And then I also took out these jumper wires, just covered in goo. Look at the residue. This one too. So this, boys and girls, is why you don't want to leave leaky caps inside of electronics. So, and here maybe it's hard to see, but these pads are starting to come off. Get focus. Come on. Come on. I don't think it likes these reflective surfaces. It's still trying to focus on the background. There we go. So you can see, like, this one here, it's coming off. Yeah, so we want to keep removing more of these components. Take these diodes here. And this solder is not melting. Just use my pliers to kind of pull them out there. Pull them out. Ugh. Yeah, lots of cap glue on those too. Look at that. Cap juice. Ugh. This is like some kind of cap juice porno video. Ugh. Let's keep going. So I want to remove all the components, probably like this quadrant. Oh no, that's too much. Oh. Oops. Obstructing. So I want to remove all components that are sort of in this affected area here. This is not cap juice, by the way. Right here, this is just flux from the factory. We clean right off. But we want to remove all components down to here, right? So we have a clean area here. We can just go crazy with the cleaning and the removal of damaged layers. This solder is not melting at all. Not melting. Add some solder to remove the solder. Yeah, it's pretty crazy. It's really not... Oh, actually, no, it came out. Okay, that did it. There we go. Yeah. Alright. Keep going. Pull these resistors out. It's so gross. Look what happened to that poor resistor. Probably want to put them... Oh, it's gross. Probably want to get new resistors all together here. Okay, I see a jumper wire we should take out as well. Nope. Solder doesn't even budge. Here we go. Oh, sorry, I forgot. I'm getting all grossed out, so I forget to the camera back. It's so stuck in there. I'm using a little bit of force. So normally I would be more careful, but I'm, you know, less and less believing that this is a salvageable power supply. Okay. So another jumper wire out, like so. Ugh. It shouldn't be brown like that. So we probably want to get this transformer out as well, which is not going to be fun, but it's sitting right on top of the corrosion. And so there's all these components here. It's quite a lot. Even with the fume extractor, the air in here is getting really stale and gross. I'm getting careless. Scratched the board a little bit there. It's just, it's not good to be doing this at all. Oof. These fumes, man. Components are starting to fall onto the floor. Sorry, no, onto my desk. Alright, let's see it. We have one component falling off here. Let's see if we can just pull the others out. Like so, yeah, transistor came out. Capacitor. Still stuck on there. Diode. Oh yeet. Ugh. You can really see it swimming in cap juice there. Look at this. Ugh. that. Just by pulling out those components, right? You can see there was a, because I thought I cleaned this pretty thoroughly the first time, a couple of months ago when I did this. I scrubbed it with alcohol, but there is a lot left. One jumper. Came out. So I think we want to finish it up until the edge of this IC here. I don't think the IC is affected. Infected. One more jumper come out. And I think we're done in that area. And they also just want to pull out these caps. And replace all these caps. I'm just pulling them out. These small caps are easy to desolder. You can cheap by kind of holding onto them, applying some heat, pull gently. They kind of come out. Unless you're heating the wrong legs. Oh. Alright, let's pull all the caps out. that's it, except for the big one. I'll leave the big one for now. And last but not least, I wanted to remove the transformer. This could be fun. This is not too bad. There's enough of a surface to work on. Apart from, unlike the little components. See if we can wiggle it out. Oh, there's one more over here. Not to forget. And came right out, like so. That's not too bad. And the reason I'm doing this is, yeah, of course, these legs here are a bit cap juicy. You want to get rid of that. And also you want to clear out this entire area here, so we can just clean it very thoroughly without having to worry about stuff being in the way. Let's remove this one last jumper wire. Yep, that was a good thing to see. There's cactus hiding underneath. So gross. I want to pull out from this diode as well, so I can see it has cactus on one of its legs. And I think that should be it for the damaged area. That's quite a lot. I think we can get away with not removing this, or actually there's corrosion going up here as well. But I don't really want to remove this heatsink and like 3 voltage regulators sitting on it. So that's the one shortcut I'll take. So I'm gonna wrap it here. I think that was pretty labor intensive, not what I was intending to do. I'm gonna prep for. So I made a bit of a mess here. All the components are kind of lying around. It's really dirty. I'm gonna sleep on this and make up my mind whether I actually want to try and fix this power supply, because even if I clean this very thoroughly and put this all back together, recap it, it's gonna be this part here is gonna be really weakened, like all of the corrosion that's gone into all these traces, all these through holes. This is not gonna be a very long-lived power supply probably. So I think I'll go back to try to figure out how to adjust the other power supply instead again. and see if I can take that route instead. Or maybe I can try to recap that one. Yeah, I guess it's not too bad. But there are some very weak pads on there. So basically, one thing, I'm gonna grab. I have like. Let's see if I can find it. I have some crappy desoldering wire that this works really poorly, but I can use it as a cheap way of like scrubbing a little bit. Let me just scrub these pads. And I just scrub the weakened solder so what's it called? Getting tired. The weakened solder mask is starting to literally just peel off. Oops, that's not good. My wheat got stuck. Uh-oh. Yep. That pad there is very loose. So yeah, so that's that's where we're at. Turn off my iron. Too much glare. It's better. Yep, so that 10% done cleaning that mess up. So I'll wrap it there. Thanks for watching, and I'll get back with announcing my next steps in the next next video, next stream. So have a great rest of your day, and bye.